Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 19, 2026, just 2 days ago. It introduces a massive new vision-language action model trained on 35,000 hours of data, achieving a record-breaking 99% success rate on the Libero benchmark by treating human movement as a universal language for robots. The paper is titled, Being-H0.5, Scaling Human-Centric Robot Learning for Cross-Embodiment Generalization. And as we'll see later, the results for transferring skills across completely different robot bodies are really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the 2 billion parameter Being-H models are ready for download. The pages include Python inference code and server scripts for robot control. Figure 1 provides a complete snapshot of the system, starting with the data foundation on the left. This panel introduces Being-H0.5, a massive corpus containing 35,000 hours of mixed human and robot interaction data. Moving to the center, the architecture diagram shows how the model unifies this data, using a shared attention mechanism that splits into specialized experts for understanding and generation. The charts on the top right confirm this approach works, as the blue bars show superior performance over baselines. Finally, the bottom section demonstrates real-world success, showing robots stacking bowls and arranging flowers. So, Figure 2 breaks down exactly what constitutes that massive Being-H0.5 dataset. The top section highlights the human component, which spans 16,000 hours of diverse demonstrations, ranging from lab settings to daily life and aligning physical motion with language. Down in the bottom left, we see the robot manipulation data, covering 14,000 hours across more than 30 different robot bodies. Finally, the green panel on the right adds 5,000 hours of vision-language understanding to help with reasoning. Alright, while Figure 2 gave us the big picture, Table 1 details exactly where those 14,000 hours of robot manipulation data come from. It lists 30 distinct embodiments, categorized by their physical structure. We see a huge variety here, from standard single-arm robots in the top section, like the Franca, which contributes over 2,000 hours alone, to complex dual-arm systems and humanoids listed below. The columns also reveal a strategic mix of data sources. For instance, the Ajubot G1 combines both real-world and simulation data to reach nearly 2,400 hours. This diversity in kinematics and end effectors is what forces the model to learn general physical principles rather than just memorizing specific hardware controls. So while Table 1 listed the hardware, Figure 6 lays out the architecture. On the far left, the unified action space addresses the hardware variety by mapping human hand motions and robot controls into compatible slots. In the center, the main schematic reveals a split design, a blue understanding expert for perception, and an orange action expert for movement, linked by shared attention. Below that, the Being-H0.5 panel shows how data is serialized into a consistent question-answer format. Finally, the bottom right introduces the mixture of flow mechanism, which routes tokens to specialized experts for efficient control. Okay, Figure 6 showed the high-level design, but Figure 7 dives into 2 specific modules that keep the robot stable in the real world. On the left, manifold-preserving gating handles noisy sensors. It measures the discrepancy between observations and expectations, using a gate to balance trusted priors against potentially jittery new inputs. On the right, universal async chunking adapts to timing differences. Since latency varies by robot, it splits the action plan into a committed prefix that is already executing and a predicted postfix for future steps, ensuring smooth control. Well, having covered the architecture, Table 4 now presents the payoff on the standard Libero benchmark. The table compares success rates against strong baselines like Open versus LA and Pi 0 across 4 task categories. Looking at the bottom rows, the results are striking. The specialist version of Being-H0.5 achieves an incredible 99% average success rate, effectively solving the benchmark. Even the generalist model scores nearly 98%, showing particular strength on the long horizon tasks in the 4th column, which require complex multi-step reasoning. Wrapping up, the key lesson here is that human movement can effectively serve as a universal language for robotics. By leveraging the massive Being-H0.5 dataset, Being-H0.5 shows, we can build foundation models that generalize across diverse hardware, bringing us one step closer to truly general-purpose embodied AI. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.